Hello everyone, so today in Algebra 1 video we're going to cover how to solve equations with variables on one side. So we're going to walk through these examples and kind of explain how to solve these examples. So the first one up here is given with 5x plus 2 is equal to 12. So if you recall your PEMDAS videos, you have to look at your operations before you're solving your equations. So you notice that you have addition and multiplication here, which means you'd have to divide and subtract here. Now, whenever you're solving for your x value, you're going to do the exact opposite of what you do according to PEMDAS. So if you have 3 times 4 plus 5, you're going to do your 3 times 4 first, and then you're going to add 5. But if you have 3x plus 1 is equal to 4, you're going to subtract your 1 first and then divide by 3. So you're going in the opposite order. Now, why is this? Well, usually equations have some sort of process when you're solving. So we're going to walk through this process and then display that when solving these questions. First thing we're going to do in any of these problems is we're going to combine like terms if there are any, right? So now we can, by combining like terms, you guys are able to simplify a lot of the values that, that might seem far apart. So when you combine like terms, now you can solve for your x value. First, you're going to solve for the x. Now, there are going to be 2 solve for x steps. I'm going to expand on this just a little bit. So the first solve for x step, you're going to get x by itself. So in many of these questions, you're going to have x multiplied by some sort of number. And what their second step is doing is we're making sure that that x and the number are by itself on either the left or right hand side of the equation. In the third step, we're actually solving for our specific x value. So this might be just a little bit confusing, so I'm going to clear that up with the first example. So we'll go through all these steps. Step 1, 5x plus 2, there are no like terms, so there is nothing to combine there, especially on the left hand side. And on the right hand side, well, you just have 12, so once again, there are no like terms. Now you're going to solve for x by itself. By this, we're going to get the 5x to be on one side by itself. So to do that, we'll subtract 2 from both sides, and we get 5x is equal to 10. Now that's what step 2 does. It solves for x and its coefficient by itself. And step 3, you're going to actually solve for your x value. Now you're going to divide by 5 because x is being multiplied by 5, so you're doing the exact opposite, and you're going to get x is equal to 2. Moving on to our second question. Okay, well now we can actually combine some like terms here. So you can ignore the parentheses because there's nothing to be actually combined within those parentheses. Keep in mind that 3x and 4 can't be combined because 4 does not have an x, so it's not a like term. But there is a 5x over here. So if you combine like terms, you get your 8x plus your 4 is going to be equal to 12. Now we'll do our step 2 solve for x, which is to get our 8x by itself. So you subtract 4 on both sides, and now you get 8x is going to be equal to 8. Divide by 8, which is going to be your third step, just solving for x by itself without the coefficient. 8x is equal to 8, sorry. And you're going to get x is equal to 1. Now moving on to the third question, well, there's going to be a step that we have to do before combining like terms in this case. Now what this step does, it just simplifies combining like terms because you don't have to worry about the numerator as opposed to the denominator. So you notice that 9 is perfectly divisible by 3. So you're just going to simplify that 9x over 3 to be 3x. Rewriting this, you get 3x plus 4x plus 5 is equal to 12. Now you can combine like terms, combine the x's, since there's no other just number term, and you're going to get 7x plus 5 is equal to 12. So that was our step 1. Now we're going to solve for the x and its coefficient by itself. So we're going to isolate that 7x term you see. Keep in mind that this is isolating x plus coefficient, and this is isolating just x. So here we move 5 to the left hand side, or the right hand side, sorry, and you get 7x is equal to 7. So now you can isolate x by itself, and once again you get x equal to 1. So These are just basic examples on how you solve for variables on one side. Now, bringing the x back in, we're going to talk about this just a little bit. So why do we do the opposite of PEMDAS? Because that helps us actually isolate our x variable. So if you look at one of our examples, 3x plus 1 is equal to 4. Usually you do multiplication, then addition, right? You do multiplication first, then addition. But you're solving for x, so you have to do the opposite. It's kind of like taking a step backwards instead of forwards, which is why instead of doing multiplication addition first, you're going to do the exact opposite. You're going to do the exact opposite order and the exact opposite, addition as opposed to subtraction. You're going to do the exact opposite. So instead of addition here, you're going to subtract. And instead of multiplication here, you're going to divide. So in the next video, we're going to cover how to solve equations with variables on both sides instead of just one side.